We're going to cover 7.3 and 7.4, just the first half of 7.4. But to start off, I have some homework questions that we're going to work through. Okay, so I chose some homework questions that I figured you guys might have questions on. For the word problems, I'll set them up and you can finish them. We'll work through this one here, and I'll work through one of the inequalities, and then you can finish the other one. I'll just show you how to set it up. Okay, so for number 20, we need to figure out what our common denominator is. In order for us to do that, we're going to have to factor this first. Okay, so we're going to be doing SMILE method here. We'll have a 2x there and an x there. And then this can either be a 2 and a 2 or a 4 and a 1. Since we're looking to score a 7 in the middle there, might want to put a 4 there and a 1 there. And then we see that that would give us 8 and 1 when we check that. So we want positive 8, negative 1. And then, looking over here, it looks like we're going to need a 2x minus 1 and an x plus 4 for our common denominator. All right, so then we just kind of add the pieces that we're missing. So over here, I need the x plus 4 on top and bottom. And over here, 2x minus 1 on top and bottom. And then over here, I have everything. So once I get those common denominators, I can cross out the bottom and just work with the top. So let's multiply that through there, multiply that through there. So I have x squared plus 4x plus 6x minus 3 is equal to 21. And then we just go ahead and solve from there. So we have an x squared and an x in the problem. So we'll have to combine like terms, move the 21 over, then we'll have to factor, and we'll get two answers out of this. So we have 10x. If I subtract the 21 from both sides, I get a negative 24 is equal to 0. So we'll factor this. Okay. So two numbers that multiply to 24 and add to a 10. You could think 8 and 3, that's not going to be it. We can think 6 and 4, that's not going to work either. But we can also think of 12 and 2. Okay. So x plus 12, x minus 2. And that's equal to 0. So we're just trying to figure out our 0. Okay, we get x is equal to negative 12. And then for this one, we get x is equal to 2. And remember, double check. Make sure that you can plug a negative 12 and a positive 2 in there. And we can, so those are both solutions. All right. For 23 and 24, I have the answers there with the problem. But I want to show you how to get to the answers. Okay, so we want, for this one, we're going to have to set it up as total cost over total weight. And we want this to equal $1 a pound. All right, so we have 3 pounds of bananas at 90 cents a pound. Okay, how many pounds of apples costing $1.25 per pound? We don't know how many pounds of apples we're going to have, but we want to add those together because that's the total cost. So say 125 times x, which is the weight that we're going to find. And down here, we have 3 pounds of bananas plus x pounds of apples. I don't know. What I need for apples is equal to 1. And then you can go ahead and solve this. Okay, so we're going to need a 3 plus x on the bottom here. We're also going to need a 3 plus x over here. So if we just multiply this one like this, 3 plus x over 3 plus x, the denominator will cancel out. Or you could have just said multiply this out, right? That was another way to do it. Maybe you don't want to think about the common denominator. You just multiply both sides by 3 plus x and you get the same thing. Okay, so then we would have 3 times 0.9, which is 2.7, plus 1.25x equal to 3 plus x. And put the x's on the same side. So let's move the x over and then put the 2.7 on the other side. And we'll get, if we subtract 1, right? So 1.25 minus 1 is 0.25x is equal to 0.3. I divide both sides by 0.25, and I get x equals 1.2, and that's pounds. Okay, so I needed 1.2 pounds of apples in order to get my total cost to $1 a pound. So the next one, we have one just like this on the notes. Okay, so Brian's volunteer group can build a garage in 12 hours. So that's one job in 12 hours. Okay, Sequoia's group can build it in 16 hours, so one job in 16 hours. How long would it take them if they work together? So that would be one job in X amount of hours. I don't know how long it's going to take them to do that job together. All right. So we just need to solve this one. We can figure out what our common denominator is going to be. So between a 12 and 16. So this is probably, we would start taking multiples of 16. So 16 doesn't work, 32 doesn't work, 48 is the next one. That's the one that we want. So we need a 48x. Okay. So this one, I think it would work better if we multiply everything by 48x rather than getting a common denominator. So 48 and 12, that'll cross cancel to 4, right? 12, 24, 36, 48. So I would take the top times 4. So we'll have a 4x for this one when we multiply it through there. And then over here, we're taking it times the 48x. So 48 and 16 would cross cancel to a 3. So we'll have a 3x for that one. And then we're taking the 48x times 1 over x. The x would cancel. We're left with 48. And then from there, so we multiplied out the fractions. We have something really nice to work with. So we have 7x is equal to 48. Divide both sides by 7. And we get x equals 6.86 hours. So it takes them 6.86 hours if they work together to get the job done. All right, on to 26 and 30. For number 26, we're working with an inequality. So remember, these were the ones that had quite a few steps to them. So we had to find our restricted values. Let's list that one off to the side. So a cannot be 0, because that would make that a 0. That would make that a 0. And then we actually had to solve it. So we kind of forget about this, solve it like normal. So we need between a 3, 4, and a 6. We need a common denominator of 12. And then we also need an a. So we need a 12a on the bottom. Okay. So this one, we would take it times a 4. This one would be times a 4. This one would be times a 3, times a 3, times a 2a, times a 2a. Okay. Forget about the denominator. And then go from there. So we have a 20 minus 9 is equal to 5 times 2a, which is 10a. So 20 minus 9 is 11, and then we have 10a. So we get a wonderful fraction of 11 over 10. All right, so we have a equals 11 over 10. So these two values go on a number line then, and then we're back to working with our inequality that we started with. Okay, so let's make our number line. So we have a 0 there, we have a 1, and then a 2, and then we draw our intervals. So we need an interval at 0, and then 11 tenths, that's a little over 1, that's a tenth over 1. So we have 11 tenths, and then this is 0, those are our intervals. And then remember, we needed to check some things around these intervals. So we needed to check something to the left here, check something in between here, and check something to the right. So this might be best just to kind of, since we don't have nice numbers to throw fractions in there, let's just pick whole numbers. So we'll have x equal -1. We'll check this one out. We have x equals 1. We'll check this one out. And then we have x equals 2. We'll check that one out. Okay? So we actually have to plug those in, see what we get back out. So if we plug in a -1, we'll have 5 over 3 times -1. So that's -5/3. And then in this one, it'd be 3 times 4 over -1. So it'll be a positive, because that's going to switch that sign. Positive 3/4. And then is that greater than 5/6? So when you're looking at this one, this might be kind of handy to have a calculator on hand, because it might be a little more difficult to do these in your head. So if you just do -5 over 3 plus 3 over 4, that gets you to a negative number, right? So this is 1 2/3. This is only 3/4, so that's still a negative. So is that greater than 5/6? No, this one's out. So this interval is out. Let's check the 1. All right, so 5/3 minus 3/4 greater than 5/6. So again, you might want to double check this one in your calculator. So this is 1 2/3 minus 3/4. And if you didn't want to use a calculator, we can do like we just did up here, multiply everything by 12. So if I take these all times 12, 12 times 5/3, the 3 and the 12 will cross cancel to a 4, which gets us to a 20. And then here, 12 will cross cancel with the 4 to give us a 3, so it's 20 minus 9. And these will cross cancel here to a 2, so I have 10. So 20 minus 9 is 11. Is that greater than 10? Yes, this interval works for us. Okay, and let's try the last one, and maybe we'll do that again where we just multiply out the common denominator. Okay, so let's move this one out of the way. Plugging in a 2, so we have 5 over 6 minus 3 over 8 is greater than 5 over 6. Okay, so here we're going to multiply through by a 24. If you want to do it this way, so 24 and 6 cross cancel to a 4. That gets me to a 20. 24 and 8 cross cancel to a 3, which gets me to a 9. 24 and 6 cross cancel to a 4 times 5 is 20. So 20 minus 9, that's 11. Is 11 greater than 20? No, it's not. That's out. So we only have, if we draw our little number line graph now, we have this information. So we had to go from 0 to 11 over 10 because that interval worked. And remember, we're using these numbers when we actually write our answers. So we have to be between 0 and 11/10. So that is your solution for that one, right? Because we're between our intervals. So you have to remember every time we say between something, that's how we write it. All right, so let's see if we got enough room for number 30 over here. This one I'm just going to set up, and you'll have to solve it from there. So you'll have to do the intervals and the checking from there. I'll just set it up for you though, okay? So common denominator, we have an x plus 2, we have an x minus 1, and we have a 2. So we're going to need one of each of those, okay? So we'll have 2, x plus 2, x minus 1. Okay, that's our common denominator. So we're going to multiply here by a 2 and an x minus 1. All right, 2 x minus 1. And here we're going to multiply by a 2 and an x plus 2. 2x plus 2. Okay. And then over here, we're going to have to multiply by the x plus 2, x minus 1. All right, so once we get those common denominators, we forget about the bottom. We work across the top. So this becomes 2x. So that's 2x squared minus 2x. This one becomes, so that's a 1 times a 2, which is a 2. So this is a 2x plus 4. And then remember, we change that to an equal sign. This over here, we're going to have to FOIL. So x squared minus x plus 2x minus 2. And these will cancel to give us a positive x. And now we distribute the 3 through there. All right, so we have 3x squared plus 3x minus 6. So, kind of a doozy of a problem. And we didn't list our restrictions in the beginning, but I'll come back to that. So we need to put everything on the same side because we have an x squared and an x. Maybe we'll simplify a little bit. Those are going to cancel out. All right, so minus 3x squared from both sides. So we'll have a negative x squared. Move the 3x over. And then add the 6 to both sides. So that gets me to a positive 10. Oops. Okay, so now we're going to have to factor this. Remember, you don't want to have a negative x squared, so we can multiply everything by a negative 1. And that'll change our signs. So we'll have x squared plus 3x minus 10 equals 0. And then we factor, we'll have x plus 5, x minus 2. So our answers are going to be x equals negative 5, x equals 2. Okay, so we're going to need those we also need our restrictions in the beginning. So I'll have x can't equal -2, x can't equal 1. So this one has quite a bit to it if we're making intervals. Okay, so you might just want to use your calculator when you check this. It's going to be kind of beefy when you start plugging stuff in, but I'll set up the intervals for you. So we're going to have, let's put a 0 right about here. And let's draw that out. And 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so we're going to 5 and -5. And let's draw our intervals in green again. So I'm going to have interval at -5, interval at -2, interval at 1, and interval at 2. So that means you're going to have to check something out here, check something here, check something here, check something here, check something here. So I would really recommend probably just putting this in your calculator. Put this this side right here in your calculator, just like we do with an XY chart, and then you can just reuse what you typed in. So whatever you put in the X, put it in parentheses, and then you can just reuse it, and it'll be quick switch where you just put a number in and go from there. Okay. So try to finish this one out. If you have this much, that's probably enough. You need the general idea. These will be more like what you're going to see on a test or a quiz. Okay, you're not going to have one that's as big as this. All right. So let's check out the last problem here. I'll set this one up and you can finish solving it out. So I have the answer there. You're going to have to follow along and show the work. Okay, so a plane takes 20 hours to fly to its destination against the wind. The return trip takes 16 hours. If the plane's average speed in the air is 500 miles per hour, what's the average speed of the wind during the flight? Okay, so we're going to need to use distance equals rate times time for this problem. The distance is the same, okay, so the flying the destination and then the return trip, so the distance is going to be the same. So we're going to have a rate times the time one way is equal to a rate times the time going the other way, okay. And so remember in the notes from the other day, we had the rate was the airplane with the wind speed and the airplane against the wind speed. So we'll say this is against over here, and then this is with the wind. All right, so if we're flying against the wind, it's going to subtract that wind speed. So we have 500 minus x. So that's going to be the rate going against the wind, and times the time, which is 20 hours. Okay, so that's the left side. And then the right side, we're going to have 500 plus x. And that's the rate going with the wind, because the wind's going to push on us and speed us up. And we have 16 hours. So this is how you set this one up. Pretty straightforward. Just distribute to 16, distribute to 20, and then solve, and you'll get 55.6. Okay, so those are your homework questions that I figured you might need help with. So please finish those when you get some time. And we're going to start with the lesson. Okay, so again, we're looking at 7.3, and the first half of 7.4, we're graphing reciprocal functions. And those are what we've been working with, essentially. They're called reciprocal functions because they have an x in the denominator. And then the second half of 7.4a, or the second half of the lesson, 7.4a, deals with graphing rational functions, which are strictly fractions with variables in them. Okay, so when we graph these, they're going to look like hyperbolas. Okay, you may not have heard of this word before. You may not have seen this before. Hyperbolas are kind of like two parabolas. They're kind of going opposite directions. All right. So when you're looking at domain and range for these, the domain and range is all real numbers except for any excluded values. Okay, so like here, I can't put a 0 in the bottom, so it's going to be all real numbers except x cannot be 0. Okay, and that will not always be the case because we're going to have different excluded values. But when we graph these, we're going to need to figure out where our asymptotes are going to be, because this one has an asymptote on this axis, and it has an asymptote on this axis. So there are both horizontal and vertical asymptotes for these hyperbolas. Okay, it's never going to touch the x-axis in both directions. It's never going to touch the y-axis in either direction. Okay, if I were to graph 1 over x, best way to do it would be an XY chart. And since this is just 1 over x and we identify that 0 is an asymptote, then I can pick numbers around 0. And you're going to want to pick 3 points on both sides of the asymptotes here when we graph, okay? So if I know that I can't plug in a 0, then I'm going to do a -3, -2, -1, and then I'm going to do a 1, 2, 3, because I can pick everything around 0. 0 would be here normally, but I can't plug in a 0, so I'm just going to use these values, okay? Let's try to work through some of the questions. So some of the questions you're going to see are just basically going to ask you for values which x or which the function is not defined. Okay, so we need to figure out what numbers we can't plug into these equations. So they're pretty simple starting out. To do this one, all I need to do, I can't see what I can't plug in right here. You could guess and check for days, but the best way to do it is to factor. So 2 numbers that multiply to give you a -24 and add to give you a 5, that's going to be an 8 and a 3. So I have x plus 8 and then x minus 3. And that's what this factors to. All right, so now it's pretty straightforward. We have this on the bottom. What goes in here to make it a 0? So x cannot be -8. What goes in here to make it a 0? X cannot be 3. So we've essentially done this already with the inequalities. You just have to find the excluded values, and you just say that you can't plug those in. All right, so now when I just kind of preview for the materials ahead, these are going to be asymptotes. Okay, so I would have an asymptote at -8, and I would have an asymptote at 3. So these are going to be invisible lines, okay, like this. So I'd have a -8. Let's say we're going by 2s. So I would have an asymptote at -8 and an asymptote at 3, and my graphs would not, they would kind of approach these lines, but they would not cross them. Okay, and then we're also going to have an asymptote at 0, but we'll get to that here in a minute. Okay, so identify the asymptotes, domain, and range of the function. So we have a graph given to us. We have the equation that goes along with the graph. We're going to identify asymptotes and domain and range, okay? So you should be able to kind of pick them out. This one you can see it's going to approach the y-axis, right? It doesn't look like we're crossing the y-axis, so that's a y equals 0 asymptote. This one you can kind of see they level off here as well, okay? But that's an x equals equation, so we have x equals 2. And you can look back at the function here. So what happens if I plug a 2 in the bottom? That's an excluded value, right? X cannot be 2. So that's where one of the asymptotes is going to be, is at 2. So I have an asymptote going horizontally and an asymptote going vertically. Now I need to state my domain and range. All right, so we have asymptotes here, and domain and range. So these are really going to give us our domain and range. So my domain is going to be everything except 2. All right, so it's going to be all real numbers, but x cannot equal 2. My range is going to be the same, except I'm going to be looking at the y asymptote. So it's all real numbers, but y cannot be 0. So that is our domain and range that goes with this function. Okay, I'm never going to cross this line, and I'm never going to cross this line. So let's check out another one. Okay, so I want you to pause the video for a little bit here, and I want you to figure out what your asymptotes are and what your domain and range are. Okay, so please pause the video, give about 60 to 90 seconds, come back and we'll look at it. All right, so this is the function that we're given, and I want you to kind of pay attention to the numbers in this function when we list our asymptotes and our domain and range. So we can kind of see that this right here is going to be an asymptote. And then if you look at the graph, the darkened lines are going by 2s. So this is going to be y equals -1. All right. And then I have an asymptote here as well. Okay. So this is x equals -2 because we're crossing the x-axis at -2. Let's look at our graph or our function here to see if we can figure out where those numbers come from. If I look here, I know that x cannot be a -2. That tells me the x asymptote. Okay? Then if I look on the back end, now that doesn't tell me an excluded value, but that does tell me the y asymptote, okay? So the y asymptote comes from here. The x asymptote comes from here. So you look at your denominator to figure out your x asymptotes, and you look on the back end to figure out your y asymptotes, okay? This is for reciprocal functions. So we have these asymptotes listed, and now we need a domain and range listed. So all real numbers except x cannot be -2, right? That's for domain, that's x values. Range, all real numbers except y cannot be a -1. So those just come straight from your asymptotes. All right, so we have this domain and range and these asymptotes. Okay? So jumping ahead, you have a general form of reciprocal functions. The variables should look similar to what we've seen in the past. Okay? The big things to pay attention to here would be this and this. All right. So you can go ahead and write this stuff down, but you can figure out most of this by just doing an XY chart and graphing it. It is important to know what this does and what this does. So if you remember back to the example we just did, this is going to tell me my x asymptote. Okay, but you want to think opposite here, right? So you always think about like, well, what's going to make this a 0? I always think opposite here. And then this one is going to tell me the y asymptote. And you don't think opposite here, you think about the same. So it's just whatever number is on the back end, that's the y asymptote. Whatever number is in here, I think opposite, and that's going to be the x asymptote. And then we're going to graph some of these. Okay? So we're going to graph this reciprocal function here. We have -1 divided by x plus 1 plus 3. Okay, so get ready for fractions here. We're going to be using some fractions. First thing you want to do is start by figuring out what your asymptotes are going to be. All right, so remember here, we look here for the x asymptote. X cannot be -1. And then we look here for the y asymptote. Okay, so that's a y equals 3. And I keep writing x cannot be -1. That's our restriction. That's the way you write the restriction. This is the way you write the asymptote. X equals -1, y equals 3. Because the asymptote is a line, not a restriction. So we're going by 2's here, it looks like. So I draw a line at -1. All right. And then I'm going to draw a line at 3, y equals 3, so that's right there. All right, so those are the asymptotes. So we have x equals -1, y equals 3. Those are the asymptotes. Okay, so now for the xy chart, now it's pretty straightforward. It's just going to be a little bit of work plugging in some values. I want to have 3 or 4 values. Actually, I want to have 4 values on this side and 4 values on this side. So I want at least 8 points. Okay, at least 8 points for these. I need values on both sides of the asymptotes. So when we plug into an xy chart, we're plugging into the x values, right? So I know that I'm not going to touch this line. So let's pick some stuff. Let's pick a value next to it. So I have -2, -3, -4, -5. Okay, those are the simple values. Now I'm going to tell you that you should probably plug in close to this line. All right, so I'm going to change this a little bit, and we're going to do a -1.5. Okay, we're going to be using our calculator for this, so we're just going to plug a -1.5 in, because that's close to this line. This is -1, -1.5 is right about here. And then on the other side, so I'm going to go to a -0.5, and then a 0, 1, 2. Okay, so we're just going to plug these values in now. So I'll show you by hand what it looks like, and then you just use your calculator to get the rest of them. So it's -1 over -1.5 plus 1 plus 3. Okay, simplifying the denominator, I get a -0.5, which this is 1/2, right? So if I have a 1 over 1/2, that would flip it and make it a 2 plus 3. So that gives me a 5. All right. Now if I plug in a -2, so -1 over -2 plus 1 plus 3. So I do this, I get a -1, -1 over -1, +1, plus 3 is 4. Okay, and we're going to get the rest of the numbers here really quick. So for those of you that have a TI-84 or some kind of a graphing calculator, you don't want to use your fraction button. You probably can. I use division because this is -1 divided by x plus 1. So you want to put those in parentheses when you have that in the bottom. Okay, so if you have more than one thing in the bottom in the numerator or denominator that are being added or subtracted, you want to put them in parentheses. Okay, so the values that I get for the rest of these, I get a 3.5 for a -3. I get a 3.33 or a 3 1/3 for -4. And then for -0.5, I get a 1. For 0, I get a 2. For 1, I get a 2.5. And then for 2, I get a 2.67. So let's go ahead and graph this. So -1.5, that's right here. We're up at 5. So 2, 4, 5. We're right about there. -2, we're up at 4. -3, so that's here. We're up at 3.5. And then -4, 3 1/3. So you can kind of see that makes my curve right here. And I have to extend it that way along that line. Okay. And then the other side should just be a mirror image of that. But we're going to graph the points and we'll make sure. So -0.5, 1, 0, 2, 1. So we're right here, 2.5. Okay, and then 2, 2.67. So we're approaching that line. And then we have the same kind of idea. So I have that curve there that looks like that. So I have a hyperbola that was created by these points. Okay, and I have the graph right there. Just might be a little bit better there. Okay, so the big thing here, I find my asymptotes. I pick points around the x-asymptote, so I cannot have a -1. It won't work. So I pick everything around -1. 4 points to the left, 4 points to the right. You want to pick points close to this asymptote. So if I'm at -1, I got to do a -1.5 and then a -0.5. You could also do a 1.1, like a -1.1, or a -0.9. That would be even closer. Sometimes you have to go that close to the line to see where it goes. Okay. Plug in my 4 points on the left, plug in my 4 points on the right, graph it, and now we needed to state the domain and range, which we could have done that from the beginning. So domain is all reals except x can't be -1. Remember, this is the way you write the restriction. This is the way you write the asymptote. And then my range, all real numbers, except y cannot be a 3. So that's our domain and range that goes with this function. Okay, so let's try one on your own. So right there's the next one. So please pause the video and take about, you probably have 2 to 4 minutes to work through this one. Okay, so go ahead and give it a shot. All right, to graph the function, you first want to find your asymptotes. So we can look for our restriction, and then we have the y asymptote back here. So I'm going to write those off to the side. So I have an x equals 2 asymptote and a y equals -1. So remember, you think opposite where the x is and the same where the y is. Okay, and those are going to help us with our domain and range. So I have x equals 2. That's going to be right here. I have y equals -1 right here. So I'm going by 2's, remember, not by 1's. Okay, so then our xy chart, we're going to find values that are close to this. Okay, so 2 is right here. I want to pick 4 points on the left, 4 points on the right. Okay, so let's pick a number that's close to that. So let's do 1.5, and then let's do 1, 0, -1. Okay, so that's our close point, and then we have 3 other points that are next to that. And then let's do 2.5, and then we'll do 3, 4, 5. Okay. Okay, so let's do the 1.5 by hand. So I have -4 over 1.5 minus 2 minus 1. So this gets me to a -0.5 down there. So those turn back positive. So 4 over 1/2 makes that into an 8. 8 minus 1 is a 7. Okay, so let's do the 1 next, so negative 4 over 1 minus 2, so that's negative 1. That gets me to a positive 4. Okay, so 4 minus 1 is 3. Then we do the 0. 0 minus 2, negative 2 down there. Those turn back positive. 4 over 2 is 2 minus 1. So 2 minus 1 is a 1. And then we'll get the rest of the points here. So a negative 1 is a 0.3 repeating. And then a 2.5 is going to be a negative 9. A 3 will be a negative 5. A 4 is going to be a negative 3. And a 5 is going to be negative 2.3 repeating. Okay, you can get all these by using your calculator or by hand, whatever you want to do. After you get these values, then we just start graphing. So 1.5, there's 1.5 is right here, 2, 4, 6, 7. So we're about there. And then 1, 3, we're there. 0, 1. And negative 1, 1/3. Okay. And I know that we're going to approach this line. I know that that's not getting close to that line yet, but as long as I have the general idea for the curve, I know that I'm going to continue this way, and I shouldn't pass that line. Let me try this again. So I'm going to approach that line right there and then follow that. And I need arrows on both ends to show it goes on forever. So go to 2.5, so 2.5, negative 9. So 2, 4, 6, 8, 9. Right there. 3, negative 5. 4, negative 3. And then 5, negative 2 1/3. Okay, so same thing here. My graph is going to go like this, and I'm going to approach the asymptote. Okay, so that's what my graph looks like. I list my domain and range off to the side here. So it's all real numbers for x, except x cannot be a 2. Okay, range, again, all real numbers, except y cannot be a negative 1. Okay, so that's our domain and range, which comes from the asymptotes here and our graph. All right, so now on to a brain break. So rock, paper, scissors, if you want to do this quick, so 1 to 3 minutes, maybe do best 2 or 3. Try it with your feet. If you don't want to do it with your feet, just use your hands. So for a rock, your feet are together. For paper, your feet are apart. And then scissors, your feet are crossed. Okay, so give that a shot if you want to give it a try, and then continue the video. All right, on to the next topic here. Kind of going with what we just did, but we're going to try to get domain and range without graphing. It should be straightforward, and then we're going to try to graph. We're going to get on to the 7.4a and graph rational functions rather than reciprocal functions. Okay, so remember, if we want domain and range, we look here and we look here. So go ahead and write those out. So for domain, we should look at the denominator, and it's always all real except x cannot be something. Okay, so then range, all real numbers, but y cannot be something. So in this case, x can't be negative 1. We think opposite that. And then y can't be negative 2. We think the same as that. Okay, so that is our domain and range for this function. And you can see that you can get it right away without even graphing it if you don't want to, because you can figure out where the asymptotes are. All right, on to graphing rational functions. For these, we have some rules that we have to follow. Okay, and I want you guys to write these down in your notes, and we're going to add to them tomorrow. Okay, because we're going to continue rational functions tomorrow. So first, start out by finding any undefined values for the function. So you find a vertical asymptote, which is called infinite discontinuity. Okay, so it's never going to touch it. It's going to infinitely close but never touch that line. It'll never be at that point. Okay, and then we're going to look to see if we can find any holes in the graph. This is coming tomorrow. Okay, the stuff we're working with today, you won't have any holes in the graph. So tomorrow we'll be looking at that. All right. So then the horizontal asymptotes are going to be a little bit more difficult to find for these ones. Okay. So with the reciprocal functions, you had a number on the back end. For rational functions, okay, that's what we're working with now, you're going to have to follow some rules in order to find your y equals asymptotes. Okay, so horizontal, those are y equals something. Okay, before you would just look on the back end. Here it's not that simple. Okay, so our rules. First one, so if the degree of the top is less than the degree of the bottom, the horizontal asymptote is y equals 0. Okay, this says a of x and then b of x, because normally rational functions you're going to have some function in the numerator and then some function in the denominator. So it could be like x plus 3 over x plus 4. This would be a of x, this would be b of x. Okay, and then we have to remember how we get the degree of the function. Okay, the degree comes from the highest value exponent. All right, so we have to look at the exponent. So this one would be a degree of 1. This one would also be a degree of 1. Okay, so this is a different rule. If the degree of the top is less than the degree of the bottom, then the horizontal asymptote is y equals 0. So you would have something like this. I would have x over x cubed, and I would have to graph that. The degree of the top is only a 1. The degree of the bottom is a cube. Okay, second rule. If the degree of the top is bigger than the degree of the bottom, then there's no horizontal asymptote. So let's move this out of the way. So in this case, you would have something like x cubed over x to the first power. Okay, if the degree of the top is bigger than the degree of the bottom, there's no horizontal asymptote. There is no y equals asymptote. Okay, and one more here. So if we have the top and bottom have equal degrees, okay, so that would be like this one right here. They're both a degree of 1. If the degree of the top equals the degree of the bottom, the horizontal asymptote is the line y equals leading coefficient over leading coefficient. Okay, the leading coefficient comes from the variable. In this case, my leading coefficient is just a 1 here and a 1 here, so I would have a y equals 1. If I had something like this, where it was 2x plus 3 over 3x plus 4, then my y asymptote would be at y equals 2/3. Okay, and then I would have to draw a horizontal line at 2/3, and my range restriction would be y cannot be 2/3. Okay, these three rules, you want to write them down. You're going to be using them for your homework. So if the degree of the top is less than the bottom, you got a y equals 0. Degree of the top is bigger than the bottom, no asymptote, no y equals asymptote. If they're the same, then you just look at the numbers in front of the x, or in front of the biggest powered variable. Okay? So, step 3, graph your asymptotes. So horizontal and vertical asymptotes, the x equals and y equals lines, graph those as dashed lines. Okay? And then pick points around them for an XY chart. These are called well-chosen points, okay? And you might need points that are really close to the asymptote. And I will show you in the next example. Okay, so we're going to try a couple of these together and see if we can figure them out. So we have x cubed over x plus 1. And for reference, I have a picture of what the graph is going to look like over here. All right? So if we follow our rules here, the degree of the top is a 3, the degree of the bottom is a 1. So that means there is going to be no y equals asymptote. Okay, there's not going to be a horizontal asymptote because the degree of the top is a 3 and the bottom is a 1. Okay, there will be a horizontal asymptote here, which is the x. Okay, because we still need to look here and say, well, what are my excluded or restricted values? So x cannot be a -1, so that means I'm going to have an asymptote at x equals -1. So we've identified the asymptotes, no horizontal one, I only have a vertical one there, so I'm going to draw a line at x equals -1, and then we're just going to go from there. Okay, XY chart, 4 points on both sides. So again, you could evaluate this without a calculator. I would recommend just putting this in your calculator the first time, and then every time maybe put the x's in, or put whatever number you're plugging in parentheses, and then you just keep going back and reusing those values in your calculator. Okay. If my x is a -1, then I'm going to pick point to the left of -1 and point to the right of -1. So I need a -1.5, I need a -2, -3, -4. And then to the right, I need a -0.5, a 0, 1, 2. Okay, so go ahead and plug these in your calculator to see what you get. Pause the video and then start it back up in about a minute or 90 seconds, and then you can see if you did them correctly. Okay, so the values that I have are a 6.75 for the -1.5, and then the -2 I have an 8, the -3 I have a 13.5, the -4 I have a 21.33, and then the -0.5 I have a -0.25, the 0 I got a 0, that one should be easy. 1 I have a 0.5, and 2 I have a 2.67. Okay, and again, if I'm doing this in my calculator, so let's say I'm doing the -1.5 in my calculator, this is what it should look like. So parentheses, -1.5, and then some people can do the little third power. You might have to do the little caret symbol, okay, and then I would press the divided by button, okay, which will give you that, or it'll give you a slash, and then the entire bottom is going to have to be in parentheses, all right. So -1.5, and if you want parentheses around that, that's fine, +1, close it off. Now I'm ready to reuse it. Okay, so I'd press enter, I get 6.75, I highlight this, press enter so I can reuse it, and I'm going to change the -1.5 to a -2. Okay, really helpful buttons here are the delete key and the insert key. Sometimes the insert is above the delete key, it looks like INS. So you have to press Shift Delete to insert. All right, let's go ahead and plot these points. So -1.5, I'm at 6 3/4. So this is 6, and then 3/4 is about there. -2, I'm at an 8, so I'm right there. -3, so I'm at a 13.5, so we're kind of up there. And then you can see all that I have here is this. So I don't know what happens when I get close to this line. Sometimes they're going to keep going down and just follow this line, but in the picture over here you can see that it goes back up. So you're going to want to do another point very close to this in order to figure out what it does. Okay, so I would probably do like a -1.1, or you could do a -1.01. That's very close to that line to see where it goes. Okay, if I do a -1.1, then I get 13.31. Okay, so I know that as I get close to that line, I'm going to be up around 13 again, so that means this must curve back up this way. Okay, so that's how we know that that part goes back up. And then similarly on the right, you might have to do, since that's at -1, you might have to do like a -0.9 to see that that's going to go back down. Okay, so I have a -0.5, we're here, and -1/4, so that's going to be about right there. 0, 0, 1.5, and then 2, 2.67, so we're kind of right there. So this one is a little bit easier to see that it's going to go down just because of that little downward trend right there. Okay, so that is the graph. These look kind of interesting sometimes, and they're going to be a little bit harder to know what's going on, But if you put it in your calculator and just reuse that, then you can do as many points as you want. You just have to make sure that you're plugging them in correctly. Okay, so I'm going to help you guys get one more set up. We're going to try it and see if we all get the same graph. Okay, so for this one, go ahead and write the problem down and then look at your notes for the rules. The top degree is a 3, the bottom degree is a 1, so that's just like this one. There's going to be no horizontal asymptote. No y equals asymptote. Alright, so there's just going to be an x equals. Alright, so now this one, it's not just a -1 or a +1. So remember what we're looking for to find the asymptotes. We're taking this and we're trying to find the excluded values. So when we did that, we had to figure out what would make that equal to 0. So add 1 divided by 2. X can't be a 1/2. That's the asymptote right there. So x equals 1/2 is our asymptote. So that means we're going to have a dashed line at 1/2 or 0.5. So if my 1 is here, then 0.5 is even closer. So we'll just kind of sketch that there. And then we'll go from there. So again, XY chart. And I'm going to be a little proactive here, and I'm going to pick points very close to 1/2. So let's do like a 0.49 on the left of it. Okay, and then we're going to do a 0, -1, -2. And then on the right, let's do a 0.51. That's just right to the right of the line. And we'll do a 1, a 2, and a 3. Go ahead and plug those in your calculator and see what you get. So again, pause the video for, I don't know, 60 to 90 seconds here and see what we get. So these are the values that I have for my graph. So we're going to go ahead and graph these and then see if we can make some sense of where everything goes. So -0.49 is very close to the line, and we're going down to about -5.88. So we're right there. And then we're at 0, 0, -1, and then 1/3, and then -2, 1.6. So we're about there. So you can kind of see this one, from what we can see with the points, is going to kind of go like this and curve down next to the line. The right hand, or the left hand side, excuse me, going to go like that. And then right on the right hand side of the line, we have 0.51, 6.63. So we're up here. And then we have a 1, 1 right there, 2, 2.67, so right about there, 3, 5.4. So you can kind of see this one. I'll have a line right next to that right there, then I kind of have a sharp turn right there, and it's going back up. Okay, so this is going to be the hard part, making sure that you plug those in your calculator correctly. Finding the asymptotes isn't bad. Remembering the rules isn't bad. Just making sure everything is plugged in correctly and it works out right in your calculator. Okay? A couple other questions you might have. I know this looks kind of ugly, but if you read it, it has a formula here. And then it just tells me to graph the function if R2 equals 15. So you just plug in 15 for R2. So this is 2R, R2, all being multiplied. So that 2 and 15 would multiply, so I would have a 30 R1 on the top, and then down here I would have R1 plus 15. This is the same thing as saying 30x over x plus 15, and then you would just graph the two of them, okay? If we were looking at our rules, x equals -15 is an asymptote, and then we also have a degree of a 1 up there and a 1 down there. So we have a y equals 30 because we look at the leading coefficients. I have a 30 up top and a 1 down there. So I'd have a y equals 30 asymptote. And then from there, you're just doing an XY chart. So we'd draw a asymptote at x equals -15. And then we draw an asymptote at y equals 30. And you could probably get away with picking points, like a couple points right next to the line and then going by 5s or something like that, because you can see our values are quite a bit bigger, okay? This one's about the same, just plug in the values and graph the function, okay? So you might have one of those on your homework, give it a shot, and we can look through it if you need some help, all right? So that concludes the lesson, and we have page 487, page 496. I highly encourage you to try to use Desmos to check your answers. You can maybe start with Desmos to see what the graph looks like, and then do an XY chart by hand. Remember, you're not going to be able to use this on a test, so this is just for helping you understand what's going on. Okay, so email me if you have any questions. Thanks for watching the video, and good luck with your homework.